All right, here we go, kids. More acid-base stuff. Now we're going to talk about naming things, which we did talk about a little bit more at the beginning, kind of in the middle of the year, how to name and formulate. We touched on this stuff. We didn't really go into too much detail. Here we're going to go into more specifics. So there's different rules for acids naming and base naming. So let's talk about the rules. So normally, if a name ends in ate, ate, it changes to ic acid. All right. If it normally ends in ite, it's going to be us acid. And if it normally ends in IDE, well, it's going to be hydro, base word, ic acid. All right. Now, using those rules, we'll go over some naming stuff in a little bit. Okay. How do I know that I'm dealing with an acid? Well, remember, acids always have H ions. So an example of that would be like HCO3. H2CO3, which would be carbonic acid. Another example would be something like H3PO4. Okay. Hydrogen first. Hydrogen first. That's your common trait between all of your acids. Always a hydrogen first, which means you have an H plus ion. Because remember, the first one's always positive in the chemical formula. Bases, really no special way of naming them. You just gotta name it like you normally do. All right. How do we know that how do we know we're dealing with a base? Well, remember, bases always have an OH at the end. Okay, so for example, NaOH, there's my base. LiOH, there's my base because there's an OH at the end of the formula. Okay, so let's go over some examples how to do this stuff. So HF, normally HF, if you just named it, it's going to be hydrogen fluoride. Okay, so what's the rule? IDE changes to hydroic acid. So it's going to be hydrofluoric acid. All right, so the ic acid, that came from the IDE. That was our rule. I changes to hydroic acid, and vice versa. Hydroic acid came from ide. So when you're doing the opposite, taking the name and changing it to the formula. This one right here, H2CO3, this normal name is going to be hydrogen carbonate. Okay, so remember, look up carbonate in the back of your periodic table on your ion list. So carbonate, what's the rule? 8 changes to ic. No hydro, so it's carbonic acid. Ic acid, 8 changes to ic, no hydro. Why no hydro? 3 elements, 2 elements. So anytime you only have 2 elements, that should also tell you that hydro is coming into play there. Here we have 3 elements, there's no hydro. What's SO3? And we know it's hydrogen, and it's going to be sulfite. Okay. So what's the rule? ITE changes to OUS. So it's going to be sulfurous acid. But if you put sulfus acid, I probably wouldn't mark it wrong because you are following the rule. It's just more of a terminology deal or more of a semantics. So sulfurous or sulfus, that'd be just fine. So OUS changes to ITE. So using our rules, let's see if we can work it backwards now, figure out the formula from the name. Well, any acid always has an H plus ion in there. So that's the first thing you figure out. Well, I'm dealing with acids, so H plus is always first. Now the problem is figuring out the next part. Okay, hydrobromic acid. Well, the hydro tells you that there's only 2 elements, H and something else. And just by saying bromic, well, you could say it's probably bromide, which is just bromine. And that's a 1-. Drop and swap the charges, HBr. So drop the charges, swap the numbers, HBr. Nitric acid, ic came from 8, so nitrate is NO3 with a -1 charge. Drop and swap the charges, it's going to be HNO3. Nitrous acid, it came from ite, so nitrite, you look it up on your periodic table, it's NO2 -1, drop and swap the charges, HNO2. So there's some examples we went over. There's some simple examples. We'll go over some more in class just to make sure you guys are thinking right. But hopefully this video kind of got your brain rethinking about this stuff, because this is the second time we talked about it. So I hope this helped, and we'll talk to you guys soon.